Hello, good day everyone. CCNA Module 4 IP Services. Let's start. IP services configure and verify inside source NAT using static and pools inside source network address translation. NAT is used to map private IP addresses on a LAN to a public IP addresses on the outside interface of the root study notes. Inside source network address translation. NAT is used to map private IP addresses on a LAN to public IP addresses on the outside interface of the router. The interface of the router connecting to the LAN network is the inside. The interface of the router connecting to the WAN is the outside. Different methods of NAT are used depending on the desired outcome. Static, pool and PAT assign inside and outside NAT interfaces. 4.1. Configure and verify inside source NAT using static and pools one-to-one mapping. Static 1. Translates a specific inside IP address to a specific outside IP address. 2. Translations are statically configured and placed in the translation table, whether there is traffic or not. 3. This is mostly useful for hosts that provide application services like mail, web, FTP, etc. Router config. IPNAT inside source static 192.168.1.10poo.bl.ic.12 router config. IPNAT inside source static 192.168.1.11 poo.bl.ic.25 pool 1. A form of dynamic NAT. 2. Many-to-many mappings. 3. Translates multiple inside IP addresses to multiple outside IP addresses. 4. Most useful when there are fewer addresses available, the pool, than actual hosts to be translated. 5. Entries in the translation table are created when hosts initiate connections. 6. One-to-one mappings are created, but it's said to be many-to-many because the mappings can vary and are dependent on the available IPs in the pool at the time of the request. 7. NAT entries are removed from the translation table and the IP address is returned to the NAT pool after a specified and configurable amount of time where the host does not communicate. Steps to configure NAT. 1. Create a pool of addresses. This pool consists of 100 private addresses from point 100 to point 199, even though the netmask covers all 256 addresses. Router config. IPNAT pool minus pool 192.168.1.1002.168.1.199 netmask 255.255.255.02. Create an access list for the inside networks that has to be mapped. Router config. Access list 100 permit IP 192.168.1.0.0.255 any 3. Associate the access list 100 that is selecting the internal network 192.168.1.0.0.255 to be NATed to the pool minipool and then overload the addresses router config IPNAT inside source list 100 pool. Minipool overload. PAT 1. PAT port address translation. 2. An extension to NAT that permits multiple IP addresses on a LAN to be mapped to a single public IP address. 3. The goal of PAT is to conserve IP addresses. 4. A PAT device transparently modifies IP packets as they pass through it. The modifications make all the packets which it sends to the public network from the multiple hosts on the private network appear to originate from a single host. A PAT device on the public network. 5. PAT is a translation method that allows the user to conserve addresses in the global address pool by allowing source ports in TCP and UDP to be translated. 6. Different local addresses map to the same global address, and the port translation provides the necessary uniqueness. 7. When translation is required, the new port number is picked out of the same range as the original following the convention of Berkeley Standard Distribution, South Dakota. 8. This prevents end stations from seeing connection requests with source ports apparently corresponding to the telnet, HTTP, or FTP daemon, for example. 9. As a result, Cisco iOS PAT supports about 4,000 local addresses that can be mapped to the same global address. 10. To configure PAT-NAT correctly the first time, you need to understand the Cisco NAT terminology and how your IP network's addresses map to each of the entities listed below. A. Inside local. This is the local IP address of a private host on your network, e.g. a workstation's IP address. B. Inside global. This is the public IP address that the outside network sees as the IP address of your local host. C. Outside local. This is the local IP address from the private network, which your local host sees as the IP address of the remote host. D outside global. This is the public IP address of the remote host, e.g. the IP address of the remote web server that a workstation is connecting to. The overload command is essential to force the router to use PAT. 4.2. Configure and verify NTP operating in a client and server mode. The Network Time Protocol, NTP, synchronizes the time of day among a set of distributed time servers and clients. NTP server configuration. Four point three. Explain the role of DHCP and DNS within the network. DHCP is widely used in LAN environments to dynamically assign host IP addresses from a centralized server, which significantly reduces the overhead of administration of IP addresses. DHCP also helps conserve the limited IP address space because IP addresses no longer need to be permanently assigned to hosts. Only those hosts that are connected to the network consume IP addresses. Domain Name System, DNS, is a hierarchical naming system built on a distributed database for computers, services, or any resource connected to the internet or a private network. Most importantly, it translates human-readable domain names into the numerical identifiers associated with networking equipment, enabling devices to be located and connected worldwide. Analogous to a network phone book, DNS is how a browser can translate a domain name, e.g. facebook.com, to the actual IP address of the server, which stores the information requested by the browser. 4.4. Explain the function of SNMP in network operations. Simple Network Management Protocol, SNMP, is an application layer protocol that allows the exchange of information on the management of a resource across a network. It enables you to monitor a resource and, if required, take some action based on the data obtained from the resource. Four point five. Describe the use of syslog features including facilities and levels. Cisco devices produce syslog messages as a result of network events. Every syslog message contains a severity level and a facility. The smaller numerical levels are the more critical syslog alarms. The severity level of the messages can be set to control where each type of message is displayed, i.e. on the console or the other destinations. The complete list of syslog levels is shown in the table. In addition to specifying the severity, syslog messages also contain information on the facility. Syslog facilities are service identifiers that identify and categorize system state data for error and event message reporting. The logging facility options that are if identifies that the syslog message was generated by an interface. 1. IP identifies that the syslog message was generated by IP. 2. OSPF identifies that the syslog message was generated by the OSPF routing protocol. 3. Size identifies that the syslog message was generated by the device operating system. 4. IPsec identifies that the syslog message was generated by the IP security encryption protocol. 4.6. Configure and verify DHCP client and relay. DHCP relay. A DHCP relay agent is a host or router that forwards DHCP packets between clients and servers. Network administrators can use the DHCP relay service of the South Dakota WAN appliances to relay requests and replies between local DHCP clients and a remote DHCP server. It allows local hosts to acquire dynamic IP addresses from the remote DHCP server. Relay agent receives DHCP messages and generates a new DHCP message to send out on another interface. Four point 7. Explain the forwarding perhap behavior, PHB, for codes such as classification, marking, queuing, congestion, policing, shaping. In the previous discussion on COEs, the uses of per-hop behaviors diffserve to mark packets were identified and discussed in detail. Today's post will identify the mechanisms to implement COEs. The 5 main categories of tools used to implement COEs are as follows: classification and marking, congestion management, congestion avoidance, policing and shaping, link efficiency, classification and marking. Classification and marking, although lumped together as one, are 2 distinct items within the COEs mechanisms to implement COEs. In general terms, they identify and split traffic into different classes and mark the traffic according to desired behaviors. Classification tools sort packets into different traffic types to which different policies can be applied. Classification can be done at every node in the network or be implemented at the edge of the network when the packet enters the network. Classification of packets can happen without marking the packets. Classification inspects one or more fields in the packet to identify the type of traffic that the packet is carrying. After the identification process, the traffic is handed to the treatment application such as marking, remarking, queuing, policing, shaping, or a combination of these. Marking writes a field within the packet, frame, cell, or label to preserve the classification decision that was reached during the classification process. Marking is also known as coloring the packet, which involves marking each packet as a member of a network class, so all devices throughout the rest of the network can quickly recognize the packet class. The marking process set bits in the DSCP or IP precedence field of each IP packet according to the class that the packet is in. Packets that are marked as high priority, such as a voice packet, will generally never be dropped by congestion avoidance mechanisms. On the other hand, if packets are marked as low priority, they will be dropped when congestion occurs. Congestion management. Congestion management queuing algorithms use the marking on each packet to determine which queue to place packets in. Each queue is given different treatment based on the class of packets in the queue. Congestion management tools are implemented on all output interfaces in a COEs-enabled network. Cisco iOS uses the following congestion management queuing methods: FIFO, first in first out, priority queuing, PQ, custom queuing, CQ, weighted fair queuing, WFQ. Class-based weighted fair queuing, CBWFQ. Low latency queuing, LLQ. Congestion avoidance. Congestion avoidance monitors network traffic loads in an effort to anticipate and avoid congestion. Congestion avoidance is achieved through packet dropping. Typically, congestion avoidance is implemented on output interfaces where high-speed links intersect with low-speed links. Congestion avoidance in Cisco products uses weighted random early detection, RED, to avoid congestion by dropping low-priority packets and allowing high-priority packets to continue on their path. Policing and shaping. Policing or shaping mechanisms are used to condition traffic before transmitting or when receiving traffic. Policers and shapers can work in tandem, they are not mutually exclusive. Policing controls bursts and conforms traffic to ensure each traffic type gets the prescribed bandwidth. In some cases, policing can help service providers maintain service level agreements, SLA. This is accomplished by throttling excess traffic above agreed SLA by dropping low priority traffic. Policing is implemented with class-based policing and committed access rate, CAR. Shaping helps smooth out speed mismatches in the network and limits transmission rates. These mechanisms are typically used to limit the flow from high-speed links to low-speed links to prevent the low-speed links from becoming overrun. Cisco COEs uses generic traffic shaping, GTS, and frame relay traffic shaping, FRTS, to implement shaping. Link efficiency. Although not exclusively COS tools, link efficiency tools are categorized as COS tools because they are often used in conjunction with COS. Both of the link efficiency tools were created outside of the realm of COS and were used as independent Cisco iOS tools. Header compression is a tool that is used to reduce the IP overhead of a real-time transport protocol (RTP) voice packet, which reduces the overall size of the IP packet. Large packets normally do not use header compression because the ratio of the size of the IP header is not significant compared to the payload of the packet. Short voice packets' IP header can more than triple the overall size of the packet, which can increase the delay of transmitting the packet to its destination. A RTP packet has 40 bytes of IP overhead broken out as follows: IP header equals 20 bytes. UDP header equals 8 bytes. RTP header equals 12 bytes. Total equals 40 bytes. Configure network devices for remote access using SSH. Configure the basic router and interface information. .9 TFTP is a network protocol used to transfer files between remote machines. It is a simple version of FTP, lacking some of the more advanced features FTP offers but requiring less resources than FTP. Because of its simplicity, TFTP can be used only to send and receive files.